3.5.2 Oxides of Silicon, Silicon dioxide. Silicon dioxide SiO2 called silica is probably the most and the most important common of silicon. In silica, every silicon atom is attached tetrahedrally to four oxygen atoms and each oxygen atom has two close silicon neighbors. Vitreous silica possesses the following interesting and useful properties. Number one, high transparency to light. Number two, very refractory, does not soften below 1500 to 1600 degrees Celsius. Number three, very low thermal expansion. Number four, excellent insulator. Number five, hard, brittle, and elastic. Number six, insoluble in water and inert toward many reagents. Number seven, it is resistant toward all acids except HF. Quartz. The common crystalline form of silicon dioxide is a hard, brittle, diffractor, colorless solid which differs very remarkably from carbon dioxide. Both carbon and silicon have 4 electrons in their valence shell and both also form 4 covalent bonds. So why should there be a big difference between CO2 and SiO2? The answer lies in the fact that silicon atoms are much larger than carbon atoms and thus tend to surround themselves with more oxygen neighbors. Silicon forms only single bonds to oxygen atoms, whereas carbon may form double bonds. Carbon in fact forms double bonds to each of the two oxygen atoms to produce a small symmetrical linear molecule or the carbon dioxide. It is volatile and reasonably reactive. The silicon atom can be approached closely by four oxygen atoms and forms a single bond to each at tetrahedral angles. The structure can be continued in three dimensions to produce a continuous giant silicon oxygen network extending out to give the massive silicon dioxide crystal. In the interior of the silica network, every silicon atom is bounded tetrahedrally to four oxygen atoms and every oxygen atom is bounded to two silicon atoms. The overall ratio of silicon to oxygen atom is 1:2 and the simplest formula for the silica therefore is SiO2. The silicon-oxygen bonds are strong and keep the atoms firmly in place. Note, however, that it is not the molecular formula for silica, but the whole chunk of silica must be considered to be essentially one molecule. The atoms of silicon and oxygen at the surface of the chunk do not have all their valence forces satisfied, as it is shown in the by the high surface activity of silica. In each of the various crystalline forms of silica, there is a special pattern which is repeated throughout the crystal in a regular definite crystal lattice. The regular tetrahedral arrangement of four oxygen atoms around each silicon persists in each crystalline form, but the SiO-Si bond angles and the rotation about each SiO bond are different in the different polymorphic species. The structure of silicon dioxide is shown and it's repeating itself again and again. When crystalline silica is heated sufficiently, it melts to give a viscous liquid having a random structure, presumably with the silicon atoms still on the average close to 4 oxygen atoms and the oxygen atoms close to 2 silicon atoms. When this liquid silica is cooled, it does not crystallize readily, but usually it under supercools tremendously and eventually becomes rigid without having undergone orientation into a regular crystal pattern. This rigid, highly under supercooled liquid is called vitreous silica or silica glass, frequently incorrectly referred to as fused quartz.